Hello there. Today we have learned about completed square form, and I'm going to start teaching about the couple of things we learned from it. So, what does the completed square form look like? Well, let's go over here to my maths display, and let's take the basic form of a quadratic equation, which is ax power 2 plus bx plus c. All right, with this over here. See if we'll make this a bit bigger. Right. This is the basic form of a quadratic equation. Now, what the completed square form does is it just pulls it apart a little bit. So what we have is a, and what we've taken out, to x to the power 2 plus bx, right? And now we've just taken this out of this little bracket here, and we've also taken out c, right? Now, what is the point of this? Why would we complete the square form? Well, what the square form allows us to do is find the coordinates of the vertex of a parabola, and it also allows us to find the axis of symmetry. Now, in order to do this, we need to go a couple steps further. So what we're going to do is I'm going to just write out the whole equation, to be honest, just in the anonymous format we have here. So we've got a, we're taken out again, and now what we're doing is we are splitting the middle equation into its factors. So we're taking another bracket in here, x plus half of bx, but because we've taken a out, we need to take b over a, right? So 1/2 of b over a, and we're putting this to the power 2 because we need to expand it into the quadratic that it is. And now this is not going to give you the proper equation unless you add in negative 1/4 b over a squared. Right? And that is what is the inside of our little expansion. Now this is all a little bit complicated when I put it into these terms, but it becomes a lot more clear once I've placed it into numbers. Okay, and then we add a little c here, and that comes out to this little complex thing here. Now this is the true completed square form, and when we take this in, sorry, let me make this big again. What does this actually tell us, right? We've just expanded the x term here, and this minus 1/4b is because if you expand this 1/2 b over a, you're going to get 1/2 b over a, right? And you need to minus that so that this equation makes sense again. But we've taken this out for a purpose. Preemptively. And that purpose is to find the x coordinate. So the component of this that finds that is this one. It's x plus 1/2 b over a. Right? And let me square this. Now, for all real values of x, nothing squared can be negative. So it always has to be equal to or greater than 0. Now, what does that tell us? Let's see what this makes. Okay. Now, what does this actually mean? It means that at the point when this equation is equal to 0, right? And this is all equal to 0. Let me actually go into Paint for this. When x plus 1/2 b a squared is equal to or greater than 0. We can see all that, right? That is the x coordinate of the vertex. So that allows us to find out the axis of symmetry as well, because at the vertex, this is the top or the bottom of the graph, which allows us to tell about which point does it repeat itself symmetrically. So this is the axis of symmetry as well. Now, in order to find the y-axis of symmetry, we need to take the other part of the equation that we had. So we need to take, go back to the maths, then we need to take the negative 1 over 4 brackets b over a squared plus little c, right? Now this gives us the y-coordinate of the vertex. So together you have this and this, which gives you all of this as your y-coordinate. So this allows you to find the vertex. So when they ask for a maximum or a minimum of a graph, you go ahead and you open the completed square form if you can and see where that takes you. Right. Now, what else can we do with this equation? Well, we can do the, we can factorize it. So we can factorize the equation to get some absolute values of x, which is quite helpful. And how do we do that? Well, we take again the basic equation of a squared minus b squared is equal to brackets a minus b and multiplied by a plus b. Neat little equation for factorization, right? And now using this, it gets a little complicated when we're factorizing things in. But what we do is we need to get the a terms and the b terms. So what does that mean? Well, for the a term, we've already got it. We've got this one here, this little square here. So that'll translate to a, and we're taking the a out in brackets because it just makes life easier with these big numbers sometimes. A is normally 1, but if it's not 1, then you always need to take it out and it helps to put it back in later. So there's the a, and then x plus 1 over 2 b over a. And then for the first one here, we've got a minus b, so a minus, and then b is going to be the term over here, this one here. However, you need to root it because this is going to be a constant number. It's just going to be around 23, 45, whatever it is. We're taking the square root of that. Let me find, where is the root button here? Here we go. Root of negative 1 over 4 b over a squared plus c. Now, this is important here. We can't just say plus c because now we've taken a out of everything. So what do? You say plus c over a to put it into the brackets because now, see, in all these big brackets over here, c is outside over here. Now, to put it back in, we need to go c and we need to divide it by a so that we can add it here. You can get the answer by adding c afterwards. However, it's going to be quite difficult because you're not going to be able to get a nice square. When you add it in and you divide it by a and you put it here and you add it with this little equation here, the second part, it becomes a good square. It can be a fraction or whatever, but it's always going to be a perfect square. Right. So now that we've added that, we can put another little bracket there. And that's the first part. That's a minus b. Now we just do the second part, which is a plus b, which is x plus 1 over 2 b over a, as before, But now instead of minusing, we add the b part now. So add minus 1 over 4. Do note though, in this part, you can't root a negative number, so we always take the absolute value of what we're getting here. So the negative is normally ignored. It does come into play, but it's going to be either way. Like your answer will just be reversed if you put it first or last. So it's plus minus 1 over 4 b over a squared. Let's put this in brackets for consistency. Okay, and now we're taking the root of this. So again, just root here, plus c of a. Right, and that's the second term. So now, to all of that, we get this, which looks a little much, I'll admit. It's really not so bad. It's just the addition of all of these. So basically what happens is these numbers will multiply in. And normally what happens is you get a denominator at the bottom here that is relative to a. So what you'll do is you'll then factorize a. So it'll be, say it's 14, you can just say 2 and 7. Or if it's negative 14, minus 2 and 7. And then what you write that out as, at the bottom, would be factor of a, so f of a, and we'll say f of a1, right, multiplied by x plus 1 over 2 b over a, and then it'll be whatever this box is. So I'm just going to put a little marker, let's call it h, right, and h is the value of, okay, no, let's do it this way, x plus h, right, h is the combination of minus this part, the second part here, and the 1 over 2 b over a. That's just a consonant, right? That's just, there's no algebraic expression in there. But the factor of a1 is part there. And what we'll do is we'll put in factor of a2, which is just the second part of a factor that you put in. So it says 14, so the factor of a will be 7, and the factor of a2 will be 2. And then that's multiplied by x plus, let's call it 1g, right? Now, you multiply this out, and what will happen is you normally get a whole number, and when you multiply it out, sorry, let's put this back in, you will normally obtain like a very convenient number. So it would be like 7x plus 7h and then 2x plus 2g. And that's that g value is obviously when you factorize it now. So it'll be x plus 7x plus 7h, 2x plus 2g, and that'll be your factor. And from there you can find the two little x coordinates. Right, and then you factorize something. So let's do an example, because all of this is like a little bit expanded, I suppose. Let's go. What a nice one. Let's do the factorization first. That would be, okay, let's scrub this quickly and take a new one. Let's actually do some paint. X squared minus 2x minus 35. Okay, now let's factorize this real quick. So we're going to take everything out from it. That's the middle of this. And we're going to go, a is 1, so we don't really have to worry about that for now. I'm going to go x, and then it's plus half of the b factor, so plus 1, right? And then we square that. And remember, now we need to add the minus 1 over 4, b of a, and a is 1, so remember it's just b. So b in this case being 2 squared, right? And then we put a big bracket around all of this, and we add c in this case c is negative 35. Right, and what this comes out to is x, let me just restart it. Plus 1 squared minus 1, because it's minus 1 over 4 times 4 is just equal to minus 1. Right, and then that's minus 5. Now, you can put this all together because a is just 1. So x plus 1 squared minus 36. 36 comes from the minus 35 and minus the 1 that was here already. Now, we want to factorize this into the format of a squared minus b squared is equal to a minus b times a plus b. So in order to do that, just increase this again. In order to do that, we go x plus 1 as our first factor. This is a, right? And for the second factor, it's 36, right? But now what we do is we just square root this. So we go to 6. So what we end up with is going to be x plus 1 minus 6 as our first one. And our second one will be x plus 1 plus 6, right? So that all translates out into x plus 5, or sorry, minus 5. And this will be x plus 7. And that's the factorized form that you've just gotten there. So it equates to the point x is equal to 5 and x is equal to negative 7, right? Because we always put in x equal to 0, and we're taking these as both probability chances for what x really is. Now, this is a completed square form. Now I want to go over a couple examples of just the basic thing of finding the line of symmetry and of finding the vertex. So we're going to take very basic ones for now. We're going to take x plus 2 squared plus 3. Right, now we're going to factorize this. So again, there's no a value here. This is already, sorry, this has already been factorized. This is a factorized equation. And we're just going to find out what is the vertex and how does that work, right? So now what we want to achieve here is find x plus 2 squared is greater than or equal to 0. And at what value is x for this particular equation, right? And so obviously for this one, x is equal to negative 2. So for that, that's our first vertex point. It's as easy as that. So we've got minus 2, comma what? Now we want our y-coordinate. Well, that's simple. Our y-coordinate is what's outside. It's this plus 3. So we've got minus 2, 3 as our vertex point. So this is the point where at the graph, on the graph that we've got, just make this a bit bigger. Right, we've now got the point minus 2x here and 3 over there, right? And this is the vertex of the equation. And when you multiply this equation out, you know that it's a parabola, so it's going to be coming down around there. And when you take the equation out of the factorization form, you obviously get ax plus bx plus c, and plus c is your y-intercept, so you'll know your point here, you know your vertex, and you can see how the graph will shape. Now at the vertex, let me just write this out, -2, 3, we've got the axis of symmetry, which is this line here. It says, where does this graph reflect upon itself? And that point is at -2 and 3. Now, because it's reflecting about the y-axis, this part here, not reflecting around here or anywhere on opposite sides or whatever, we can say at this point, -2 is the axis of symmetry. So the x value is the axis of symmetry. And this is what factorization is used for the most part. It just allows us to start plotting a more accurate image of graphs in our head. Thank you.